If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip. The question we're working on today is, let Fn be the nth Fibonacci number. Evaluate the following limit. And it's the limit as n goes to infinity of the sum from k equals Fn to Fn plus 1 of 1 over k. Smash that like button and let's get started. So there are two facts that we're going to use to solve this problem. The first fact is that the limit as n goes to infinity of Fn plus 1 over Fn is equal to 1 plus the square root of 5 over 2, which people typically denote by the letter phi. This is also known as the golden ratio. The second fact that we're going to use is if we have a function which we'll call g, and it's continuous, positive, and decreasing, then the following inequality holds. And it's that the integral from a to b plus 1 of g of x dx, so this integral is less than or equal to the sum from k equals a to b of g of k, which is less than or equal to the integral from a minus 1 to b of g of x dx. And so we'll let g of x be the function 1 over x. And you could check this is continuous. Well, for values of x greater than 0, that's what we'll be dealing with. It's positive and it's decreasing. So from fact 2, we know that the integral from the nth Fibonacci to the n plus first Fibonacci plus 1 of 1 over x dx is less than or equal to the sum that we're interested in. The sum from k equals the nth Fibonacci to the n plus first Fibonacci of 1 over k, which is less than or equal to the integral from the nth Fibonacci minus 1 up to the n plus first Fibonacci of 1 over x dx. And these integrals, the lower bound and the upper bound, we know how to evaluate those integrals, right? The integral of 1 over x is the natural log of the absolute value of x. So this definite integral on the left could be rewritten as the natural log of the absolute value of Fn plus 1 minus the natural log of the nth Fibonacci. And that's a lower bound for the sum that we're interested in. And similarly, the upper bound for the sum that we're interested in is the natural log of the n plus first Fibonacci minus the natural log of the nth Fibonacci minus 1. Okay, and so let's take the limit as n goes to infinity of the lower bound and the upper bound and see what happens. So the limit as n goes to infinity of the natural log of the absolute value of Fn plus 1 minus the natural log of the absolute value of Fn. Well, this is natural log. So the difference of natural logs is the natural log of the quotient. So this is the limit as n goes to infinity of the natural log of Fn plus 1 over Fn. Using our first fact, we know that this is the natural log of phi. So it's the natural log of the golden ratio. Isn't that crazy? And now let's do the same thing with the upper bound. Okay, and you could imagine we're going to get pretty similar results. So it's the limit as n goes to infinity, natural log of Fn plus 1 minus the natural log of Fn minus 1. Again, a difference of natural logs is just the natural log of the quotient. And as with above, using fact 1, we get the natural log of phi. So our series is bounded below by natural log of phi in the limit and above by the natural log of phi. So if we use the squeeze theorem, we could conclude that the limit as n goes to infinity of the sum from k equals the nth Fibonacci to the n plus first Fibonacci of 1 over k is equal to the natural log of the golden ratio. Isn't that beautiful? Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.